brightness discrimination, Weber ratio fraction, del IC divided by I. Additional light source. This is the additional light source. I plus del I. I plus del IC equal to short duration flash. This total I is changes del I and opaque class. This is short duration flash. Small ratio good brightness discrimination. Large ratio poor brightness. Poor brightness discrimination. Poor brightness discrimination. Brightness discrimination of at different intensity levels. Here, typical Weber ratio as function of intensity. Cone log I -4, -3, -2, -1, 0, 1, 2, 3, 4 in x-axis. That one is log I. Here, log delta IC divided by I. This is the rod. This is the cone. Okay. Here -2, 1 point -1.5 -1.0 1.5 -0.5 0 0.5 1. Typical Weber ratio as a function of intensity. Brightness discrimination at different intensity levels. Perceived intensity is not a simple function of the actual intensity. Perceived intensity is not a simple function of the actual intensity. Illustration of the Mach and band effect. Perceived intensity is not a simple function of actual intensity. Actual intensity, perceived intensity. This is the actual intensity, this is the perceived intensity. Perceived intensity is not a simple function of the actual intensity. Simultaneous contrast. Perceived intensity is not a simple function of actual intensity. Simultaneous contrast. Examples of a simultaneous contrast: all the inner squares have the same intensity, but they appear progressively darker as the background becomes lighter. Optical illusions, complexity of human vision. Some well-known optical illusions. Here. More optical illusions. Images of fixed pattern noise without series, with series and integration time of 1 millisecond. High speed image processing applications. Single images, sample images. Photos, images only. Figure various raw images, active sessions at 1000, 5000 and 10,000 frames. 10,000 frames per second, 5000, 1000. Experimental system, frame 1, frame 5, frame 10, frame 15, frame 20, frame 25, frame 30, frame 40. A 2500 frames divide yes video sequence per second. We 2500 frames per second video sequence of a milk drop splashing. Milk drop splashing. Yeah. 3 cross 3 kernel used by 4 processing elements. 3 cross 3 4 processing kernel 4 processing 4 sequence of a 16 images with a Sobel operator. 16 images 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 sequence of 16 images with a Sobel operator. Comparison with the other SMD SIMD sensors. Technology, resolution, pixel pitch, fill factor, transistor per PE type, frame rate, image processing. Alarm image. Here, these work 0.35 micrometer, resolution 6A cos 64 pixel, 35 micrometer cross 35 micrometer, 25% fill factor, transistor per PE 38, P type analog, frame meter 10,000 fps, image mask based processing, image processing. This one scamp image, this one NMD IP chip, ACE 16K, VCS 4, PVS, PVL SAR 2.2. Here convolutions, here also convolutions. That is in MMID IP, AC assisted code. In this paper, here design of a real time phase deflection detection parallel architecture using high level synthesis. In this research article, convolutional phase finder pipeline. Input 32 cross 38, 36 convolutions, 6 cross 6 convolutions, 4 cross 4 CSI FMAP 16 cross 14 cross 16 CS2 F dot map 16 6 cross 7 NI layer 16 N2 layer 1 output. From iteration I minus 1 to PA n plus 1 from PE n minus 1. That is this one here. Here from PE n minus 2. This one from PE n minus 3. Data flow model for 1 PE of the CFF algorithm for producing 2 data of NI layer. Local data flow of CSI and the kernel coefficient reusing. Sequential description of CSI. Loop nest filter number, this one, output window row number, output window column number, coefficient row number,